everybody, I hope you're doing well and welcome to the platform of Coaches. Today we're going to be solving the problem Little Elephants and Cars. The difficulty level for this problem is easy and the prerequisites required are your observation, math and number theory. So this is your educator Ansh and I hope you like my video. Let's proceed to the problem statement. Okay, now let us try and understand the problem statement. Little elephant of the zoo is like cards. He has n cards, each of which is one of 1,000 colors. The colors are numbered from 1 to 1,000. Each elephant, little elephant and big hippo are playing a following game. At first, little elephant takes some subset of cards, and then big hippo takes the rest of them. Here, the little elephant can choose to take all the cards or none of the cards. They play 1,000 rounds. In each round k equals to 1 to up till 1,000, they count the number of cards each has of color k. When the little elephant has A cards of color K and Big Hippo has B cards of color K, if A is greater than B, then little elephant scores A minus B. Otherwise, your Big Hippo scores A minus B points in this round, where your mod X denotes the absolute value of X. You are given n cards and array C, a list of colors of all n cards. Find the number of subsets among all 2 raised to n subsets for which little elephant wins the game. That is, he gains more points than the Big Hippo in total. If the little elephants take the subset at first, the answer can be huge, right? Since printed modulo 10 power 9 plus 7. Okay, now let me just summarize what the problem is saying. So basically, the problem says that two people are playing a game, your little elephant and let's say your big hippo. So let my LE denote my little elephant and my BH denote big hippo. Now, according to the problem, what you can do is your little elephant plays first and you're given an array. So let's say I have array 1, 2, 3. At the beginning, little elephant can choose any of the subset. So basically, a subset is nothing but for any array, say I have my 1, 2, 3, 4. A subset is nothing but it can be there are 2 raised to n subsets, and subset can be obtained by deleting any element at any position or none at all. So basically, if I delete 2, that means my 1, 3, 4 is one of the possible subsets. If I delete 1, 2, and 4, my 1, 3 is the possible subset. If I delete 1, 2, and 4, my 3 is possible subset for any subset like in 1, 2, 3, 4. If I delete 1 and 4, then my 2, comma 3 is a possible subset. So there are total 2 raised to n possible subsets because for each possibility, you are either deleting or you're keeping it, right? So 2 possibilities for this, 2 possibilities for this, and so on. Hence, you have 2 raised to n possibilities for all the subsets. So this is what is the definition of a subset. Now, yeah. So now, according to the problem, we are given that the two players, Little Elephant and Big Hippo, are playing. Now, Little Elephant at the beginning can choose any subset, right? So, say my Little Hippo or my Little Elephant chooses this particular subset as its current subset. So now Little Elephant has 1 and 2 with him, and Big Hippo has currently having 3 with him. Now the game starts. There are 1,000 rounds, and all of my colors are initially present from 1 to 1,000. That means all the array elements are strictly between 1 and 1,000, and they are also playing 1,000 rounds. So in each round, what they do is say my round k equals to 1 is going on. So in k equals to 1 round, they check whichever player has 1, or basically they check. So basically here A has 1, or A has 1 1 times. Here is this particular little elephant and let's say this big hippo. My little elephant has 1 that is occurring 1 time, so your count of A is 1, and my big hippo has 0 times. So that means my 1 minus 0 that is 1 point is currently awarded in the round 1. Now let's see for round 2. For my k is equals to 2 for the second round, again I have 1 2 present, so I have 1 occurrence of 2, and here I have 0 occurrence of 2. So again my 1 point is provided, which is 1 minus 0. And then for my k is equals to 3, here I have 1 occurrence of 3, and here I have 0 occurrences of 3. So here 1 is here, and here I have 0 occurrence. So here 1 minus 0, here points will be provided, so 1 point is provided. Here as you can see, 2 points are there at the end of the game. For any other k, which is k is equals to 4, both of the players have 0, right? So there will be 0 plus 0 points provided, hence it does not affect the game. So here at the end of the game or at the 1,000 rounds, my 2 points are provided here and 1 point is provided here. So if my little elephant chooses the subset 1, comma 2, he is surely to win the game. So this becomes one of the subset in which my little elephant is winning and my big hippo is losing. So I have to find all such subsets where my little elephant is going to win the game. And this is what the problem is asking. Okay, now let us discuss a very important observation in this question. For that, let me consider subsets such as 1, 2, 1, 1, and let me consider here as such a subset such as 1, 2, 2. Now, to show you, there 1 is occurring 3 times, right? So for round k equals to 1, the score will be nothing but 3 for this particular ones or count of 3, and here 1 is occurring 1 time. So 3 minus 1 points awarded to this particular player according to the rules, right? So awarding 3 minus 1, which is 2 points here, and 0 points here, is same as awarding 3 points here and 1 point here, right? Just look at the logic, right? You're awarding 3 minus 1 points here, so 2 comma 0 here. Other words, you are awarding 3 points here and 1 point here, right? So just the one player of the point, just a minusing it from here. So indirectly, it means the same thing. So that means your points gained by 1 is nothing but 1, 2, 3. That is effective count of 1s. And here also your point gained by this particular one is nothing but effective count of 1. Then we check the score of 2 as well. If I compare this 2 and these 2's, so here my 2 is occurring 2 times, so in round k is equals to 2. The points awarded will be here 2 points, and here my key is occurring 1, 2 is occurring 1 time. So effectively, 2 minus 1 point should be awarded to this particular player. That means 1 point is getting awarded to this particular player, and 0 point is getting awarded to this player. That also means that indirectly we can say that here I am getting 1 point or I am getting 2 points here and 1 point here, which is nothing but effective count of 2's here, right? So in general, we can just deduce that the number of points awarded will be nothing but the total length of the array, irrespectively, right? So we can easily get that from this particular observation. So it doesn't matter whatever points or what the values or the colors are, at the end, the awarded points effectively in the scores will be nothing but the length of the array itself. So say I am picking a subset of length 4, then there will be 4 points awarded here, and here it will be 3 points awarded here if we write the logic correctly, or if we deduce the logic in such a way. So effectively, always the one with the larger length is gonna win. So the goal becomes I just need to find the number of subsets such that subset of one length has greater than the subset of the second length, right? So here we can easily deduce that for 1, 2, 3, if my little hippo wants to win, he has to make sure that his opponent get a subset of smaller length than his. So what he'll do is he'll award the subset of 0 length to his opponent. That means at first he's gonna take all three values. So basically, to do so, the answer is nothing but NC0. So NC0 he'll give it to his opponent so that he can take all the values, and then he'll try to give one subset length to his opponent and take all the two values it itself. So what he'll do is his also answer is NC1, right? Then if he tries to take two subsets with him, or if he tries to give two subsets to his opponent, then his opponent is gonna win the game, right? Because out of three, if for two subset length, if your three subsets are there, or basically 1, 2, 3, if your opponent chooses two of the elements, then his length of subset is greater than your one length. So that is why he's gonna win the race, or he's gonna win the game, right? That is why the answer is simply NC0 plus NC1. So as you can see, for this case, you have 3C0 plus 3C1. And 3C0 is nothing but 1, and 3C1 is nothing but 3. 1 plus 3 turns out to be 4. And this is the answer for this case. For your 1132, again, you want to keep or you want to give the minimum subset to your opponent. So you give the 0 subset to your opponent, you give 1 subset to your opponent. If you give two subset to your opponent, then it will be a draw, right? Because you will have two elements with you and you give two elements to your opponent. Now, if you give three elements to your opponent, you're gonna lose. The answer is simply NC0 plus NC1 itself. So again, my 4C0 is 1 plus 4C1 is 4. The answer is 5. And the answer for this test is 5. So in general, for my even elements, my answer is nothing but say my even my n is equals to 4. Then my answer is simply NC0 plus NC1. That means my answer is up till n by 2 exclusive. So my all the n's or the summation of n, which is NC0 plus NC1 and so on, up till ncn by 2 minus 1 for my n is equals to even, right? And for my n is equals to odd, say my n is equals to 5, then for that particular configuration, you know that our NC0 is good, our NC1 is good, our NC2 is also good, but we cannot, so our NC0 and NC1 are only good cases, right? My NC2 is also good, and because opponent gets, or my opponent, I'm giving two subsets to my opponent, so 5 minus 2 is equals to 3, so I'm keeping three subsets for myself. So for odd, the answer is my NC0 plus NC1 and so on until NCn by 2 inclusive. So NCn by 2 inclusive, and your n by 2 denotes the seal of odd numbers. Your seal of n by 2. Right? So basically, it's just the summation of NC0, NC1 up till your n by 2 elements for each of your configuration. And this becomes the approach to solve this particular problem. Now you'll get a complete understanding of this particular approach when you see the code for the following problem. So let us proceed to the coding section. Okay, now let us try and understand the code for the following problem. Here what I did is, since I want to calculate the value of NCI of mathematics, I computed the factorials of all the configurations. Right, and I also want to calculate the factorial, or basically I want to calculate modulo mod. So I also initialize my modulo as 10 power 9 plus 7. And I calculated all the factorials up till 10 power 3, because in the constraints the maximum length of n can be 10 power 3. Right, then what you do is, you take your input your n and you initialize your answer as 0. If your n mod 2 is equals to 1 as we discussed in odd, then our ending becomes n integral division 2 plus 1. Otherwise, our ending becomes n integral division 2, right? So this I'm doing because, as we know, only half of the, or basically what we deduced was to choose the subset, the one with the greater length will gonna win. So I, being the little elephant, what I'll do is I'll try to give the smallest length of subsets to my opponent. So I'll give a subset of 0 length to my opponent, take the subset of n length with myself. I'll give my subset of 1 length to my opponent, take the subset of n minus 1 length itself. So that's why at the maximum I can take is n by 2 length. So after that, if I forcefully have to give a subset of n by 2 length greater than that, and that's why my opponent is gonna win. So my answer is up till only n by 2. What I do is I just traverse for the n and I calculate the value of NCI. So your NCI is nothing but your n factorial divided by your n minus I factorial into I factorial. And then using the inverse modulo function, I compute the answer. So this was a prerequisite of solving this particular problem. You need to know how to compute inverse modulo function and Fermat's little theorem. So for that, I just simply calculate my NCR up till my n by 2 elements, and the answer becomes the following case. Now let us run our code on the sample test cases to check whether everything is working perfectly or not. As you can see, we got the exact output according to the output format. Now let us submit our code on the actual test cases to check whether our code is working perfectly or not. Okay, so as you can see, we got the correct answer verdict for the following problem, and yes, this becomes the right approach to solve this particular problem. Now let us discuss what are the mistakes people can make in solving this particular problem. So here the important observation was that the problem does not affect on the colors. The colors can be anything, but the problem just affects on the whether whose subset length is greater. So whenever little elephant is choosing a subset, he'll make sure to choose a subset greater length for himself and a smaller length for his opponent so that he can always win the game irrespective of the color. So if this particular observation was clear, I think then the simple problem and the problem becomes complete mathematics and a basic inverse modulo. So yeah, if that particular observation was clear, I think one can easily solve this problem in one go. And this becomes the code for solving this problem, and there's a learning you get from watching my video. I hope you like this video. Please like, share and subscribe to our channel. Thank you.